Hello friends, welcome back. So let us continue with doing Fourier series problems. In the last video, we did 18th A, isn't it? We just find the Fourier series of f of x equal to pi minus x divided by 2 whole square. So today, let us go for 17B, okay? It is find the half range sine series of f of x equal to k in the interval 0 to pi. 17th B, f of x equal to k in the interval 0 to pi. See, they have asked for to find the half range sine series. Half range sine series means it is quite easy. Why? Because if you are asked to find sine series, you just need to find Bn. If you are asked to find cosine series, just go finding A0 and An. Okay. So the problem becomes much more easier. Bn value is, formula for Bn is integral f of x sine nx dx. Okay. Also something need to be added here, which is that 1 divided by r by 2 or range divided by 2. And what's the range given with? It is pi minus 0, which is pi. So here it becomes 1 divided by pi divided by 2. So this is your range. R equal to pi, substituting here you get 1 by pi by 2. Integral f of x is k sine nx dx. Fine. Denominator, if the denominator has a fraction, you have to take it to numerator. The denominator of the denominator goes to numerator, which means 2 becomes in the numerator and k sine nx dx. Just substitute the limits 0 to pi, 0 to pi, 0 to pi. Okay. Now take out the constant 2k divided by pi, integral sine nx dx in the limits 0 to pi. Integral sine nx is minus cos nx. Okay. So 2k divided by pi minus cos nx divided by n, because x has a coefficient accompanied. So n is put in the denominator in the interval 0 to pi. Okay. Before you go for substitution of limits, you need to draw a big bracket. Big brackets inside which you need to give another 2 brackets, one for upper limit, another for lower limit. Okay. Since the integration is with respect to x, put your limits in the x, in the quantity which is inside, which means minus cos n pi divided by n minus cos n into 0, 0 divided by n. Okay. Last class I have said that cos n pi value is negative 1 raised to n. Okay. Cos n pi value is negative 1 raised to n and sin n pi value is 0. Okay. Please memorize this formula, because in Fourier series in many areas we are going to take this. Okay. So here negative cos n pi is negative 1 raised to n. So 2k divided by pi negative 1 raised to n divided by n, that's in the upper limit bracket, minus in lower limit bracket we have minus, I put this minus here, and cos 0 value is 1. Okay. So this is the substitutions. And see here you have got 2 minus, this minus and this minus. So I take it outside. Okay. I take these 2 minus outside. So it becomes minus 2k by pi, and please write the rest quantities, which means negative 1 raised to n by n. This minus I put here, minus 1 by n. Okay. So this is your Bn value. I think let's have one more step, taking this n outside, minus 2k by n pi, negative 1 raised to n minus 1. Okay. Whenever you face such equation, such questions where there is negative 1 raised to n minus 1, you have some more to extend with. If n is an even number, negative 1 raised to n is negative 1 raised to even number is positive 1. Okay. Or also when n is odd number, negative 1 raised to odd number is negative 1 itself. So we can have two sections in here. Bn when n is equal to even. When n is even, this value becomes simply 1, isn't it? Bn value will be minus 2k divided by n pi. When n is even, negative 1 raised to n becomes 1. So when I substitute this 1 over here, I get 1 minus 1, that is 0. Also Bn, when n is equal to odd, what is that now? Bn equal to minus 2k by n pi. What is negative 1 raised to n? When n is going to be odd, it is simply negative 1. So it is negative 1 minus 1. So minus 2k by n pi, minus 1 is minus 2. So negative into negative is positive, or also 2 into 2 is 4. So 4k divided by n pi is your value. So here you can conclude that Bn has only values when n is given an odd number. I mean f of x, this is your half range Fourier series. Half range Fourier sine series means f of x equal to, see here we do not have a0 and an. So straight away we move on to sigma n equal to 1 to infinity Bn sine nx. Is that fine? And what is your f of x? It's simply k, isn't it? So k is equal to sigma n equal to 1 to infinity. K is equal to sigma n equal to 1 to infinity. Bn value is 4k divided by n pi sine nx. Be specific, I mean please write n equal to odd here. Just write n equal to odd, or you can just do like this, n equal to 1, 3, 5, etc. Okay. So hope this is clear. This is your Fourier sine series answer. K is equal to sigma n equal to 1 to infinity. We usually write n equal to 1 to infinity, but here in this question it is specified that when n is equal to odd number only, Bn value is going to exist. So let us specify the values for n. That is Bn exists for 1, 3, 5, so kind of odd numbers. Okay, 4k divided by Bn is written here and sin nx I just added it. So let's move on to the next question. I think we did 17b and 18a also. I should do now. Okay, let us do the 17a part later. I mean the interval is negative pi to pi. So I have something to set for you. Okay, so let us do that first question later, and let us move on to 18b now, which is e raised to, again it is a half range sine series. Very good. F of x equal to e raised to x in the interval 0 to 1. See here, instead of radians in the range, it is simply numbers given, isn't it? 0 to 1. Okay. So before we get into that problem, I should tell you something more. That is, see, we just looked into the problems like 0 to pi or 0 to 2 pi, etc. And the Fourier series went on like a0 by 2 plus sigma an cos nx plus sigma bn sin nx, isn't it? See, other than these ranges, we can also have ranges in the numbers. I mean 0 to 5 or 0 to 10 or like negative 5 to 5. Anyway, such kind of numericals, I mean numbers also can be there for the range for Fourier series. Okay, so we can generalize these ranges as 0 to L, okay, or 0 to 2L or negative L to L. If such is the case, if the ranges given for you is not in radians degree mode, then you have to make some changes in your f of x main expression. That is f of x equal to a0 by 2 plus sigma an cos. It's not simply nx, you have to multiply pi by L also. So it becomes n pi x by L. Here also it is the same, sin nx, it's not just sin nx, it is n pi x by L. Okay, same corrections will be there for a0, an, bn expressions also, like a0 equal to integral f of x dx is the same, and also it is 1 by r by 2, okay, and an is f of x cos n pi x by L. Initially we had only nx, isn't it? But here, since the ranges are in numericals, we must have cos n pi x by L dx. Also here 1 divided by r by 2 and here 1 divided by r by 2 integral f of x sin n pi x by L. Okay. And how you get to know the value for n? L, you just need to compare the expression with any of these three. 0 to L or 0 to 2L or negative L to L. Only these three kind of ranges will be there. Okay, 0 to L or 0 to 2L or negative L to L. Okay, so here in this question, what was the question? Find the half range sine series of f of x equal to e raised to x in 0 to 1. 0 to 1 means 0 to 1 also f of x is e raised to x, isn't it? So we have to compare it with 0 to L, 0 to 2L or negative L to L. I think 0 to L will be fine. Why? Because one more thing, that if you are asked to find half range series, then you have to compare with this thing. This is for half range series. Half range sine or half range cosine, you must compare it with 0 to L. If it is a simply find the expression for Fourier series, you must compare it with 0 to L or 0 to 2L. Okay, I mean 0 to 2L or minus L to L. So these are for full series, full range series. And if the question is to find half range sine series or half range cosine series, compare it with 0 to L. Okay. So this is our question, is to find the half range sine series of f of x equal to e raised to x in 0 to 1. So since it is a half range sine series given, you have to compare it with 0 to L. So comparing, we get L equal to 1. Okay. Now let's move on to finding half range sine series. Okay. Let's move on. Sine series means just you need to find the value for Bn. Bn is equal to integral something to something f of x sine, it is n pi x by L this time. Why? Because we are dealing with numbers in the range. Okay, and here the limit is 0 to 1. So here it becomes 1 divided by range by 2. Range is 1 minus 0, isn't it? Range is 1 minus 0. So range by 2 is half. Okay, so here it becomes 2 integral, this 2 becomes, this 2 goes to numerator, isn't it? So it becomes 2 integral 0 to 1, what's f of x? It is e raised to x sine n pi x divided by L. L value here is 1. Okay, dx. So while integrating this, we cannot have table method like I described in the last video, because here we have an exponential function and also this is an exponential function, also a trigonometric function. So we cannot have the table method. Table method is only for the combination like AT, algebra and trigonometry, and algebra and exponential. Okay, exponential and trigonometry we cannot have table method. Also, if exponential and trigonometry is coming, there is a quite two formula to by heart. Okay, and that is integral e raised to ax sine bx dx is e raised to ax by a square plus b square a sine bx minus b cos bx. Similarly, integral e raised to ax cos bx dx is equal to e raised to ax by a square plus b square a cos bx plus b sine bx. Here in this case, we have to make use of this formula, e raised to ax sine bx. Okay, e raised to ax sine bx. So let me write a and b value here. A is equal to coefficient of x, it is 1, and b value is coefficient of x, isn't it? Sine bx. So here it is sine n pi x. So b value is n pi. See, I just wrote this expression along with this. Okay, at times when the integration was to ask integral e raised to ax cos bx, something like that, you have to make use of this formula. For this question, it is first formula is only needed. Okay. Please make it as a note. Okay, now let us substitute the answer, which is 2 into, it is like e raised to ax, which means e raised to ax. A is 1. So e raised to 1x divided by a square plus b square is 1 plus n square pi square into a sin bx is 1 sin bx. B is n pi, right? Minus b cos bx is n pi cos n pi x in the limits 0 to 1. Before you go for limit substitution, have a big brackets inside which you need to have two others. One for upper limit, which is 1 is our upper limit. Substituting it for x, we get e raised to 1, isn't it? E divided by 1 plus n square pi square into 1 into sin n pi into 1. Sin n pi, we had it like sin n pi value is 0. So, it is like 0 minus, and when I substitute this 1 value for x, I get cos n pi. Cos n pi value is negative 1 raised to n. Never forget those two equations. So, n pi into negative 1 raised to n. Okay. N pi into negative 1 raised to n. That's it. And for lower limit, it is like e raised to 0 by 1 plus n square pi square. E raised to 0 is 1. Any number raised to 0 is 1. So, 1 divided by 1 plus n square pi square into, what is sin 0? Sin 0 is 0 minus what is cos 0? Cos n pi into 0, isn't it? When we substitute the 0 value for x, it becomes cos 0. Cos 0 value is 1. Okay, cos 0 value is 1. So, n pi into 1. Okay, that's it. Now, reducing it, you get 2 into, I think 1 plus n square pi square and 1 plus n square pi square is common. So, I can take it outside like 1 plus n square pi square. Inside it is like e into negative n pi, negative 1 raised to n minus, this is taken outside, so we are left with negative n pi, isn't it? Negative n pi. So, it is like 2 divided by, I think we can take this n pi, negative n pi also outside. See, negative n pi, and here also negative n pi is there. So, we can take it outside. 2 into negative n pi is taken outside. We are left with e into negative 1 raised to n minus 1. Okay, so this is your bn value. Again, as I said, we can have two more sections, like when n is going to be even number or n is going to be odd number, but nothing is going to be 0, isn't it? When n is given even number, it is simply like e minus 1 inside the bracket, or if n is going to be odd number, it is like minus e minus 1. So, nothing is going to be simplified. So, let us keep as such itself. Okay. In last case, we didn't have this e. So, while we substituted n equal to even number, the bracket inside the value was 0. Okay, so f of x equal to, since this is a half range sine series, let us have this term only, n equal to 1 to infinity bn sine n pi x by l. Remember, it is our range is in numericals. Okay, so f of x is e raised to x is equal to f of x was e raised to x. Remember, see, our f of x was e raised to x. So, it is like e raised to x is equal to sigma n equal to 1 to infinity bn. Bn value is negative 2n pi divided by 1 plus n square pi square e into negative 1 raised to n minus 1 sine n pi x by l. Remember, l value was 1. So, this is your answer. Let us get into the next question, which is f of x equal to x sine x in the interval negative pi to pi, which is 17a is f of x equal to x sine x in the interval negative pi to pi. See, why I kept this question to final, because here the range is a symmetrical behavior. You can see like it is like in negative L to L or negative 10 to 10, negative 2 pi to 2 pi, etc. So such ranges are like lower limit will have a negative sign and upper limit will have a positive sign. In both magnitude wise, both will be the same. So such ranges are called symmetrical range. Okay, so here you can just check out for the type of function. If such ranges are given, you have to check out the type of function. What type of function is f of x, whether it is an even function or an odd function. Why we are looking for this means, if it is an even function, we can directly write like a naught equal to 0, you can directly write like bn equal to 0, and if it is an odd function, you can write like a naught equal to 0 and an equal to 0. Okay, that's it. Now how to identify if a given function is odd function or even function. Okay, you can check like f of x is equal to x square, let it be x square. Now to check whether this function is even or odd, you have to find f of negative x first, which means instead of x, please substitute negative x. So it becomes negative x the whole square, which is x square itself. Isn't it? Negative raised to even number is positive. So it is like x square, and again we can write it like f of x. So whenever it is like coming f of negative x and f of x are equal, you can say that the function is an even function. Or in the other way, if f of x equal to x cube, let us take other function which is x cube. Okay, now please check out for f of negative x and negative x the whole cube. It is like negative x cube, isn't it? Negative raised to odd number is negative. So you can write it like negative x cube is simply f of x. So you can have it like f of negative x is negative of f of x. Then you can say that the given function is an odd function. Okay, so we have to check the same for this function also, but you have got another idea too. That means I will tell you which all are even functions now and which all are odd functions. Every numbers, I mean x raised to even number is always even function, and x raised to odd number is always odd function. Also cos x is an even function, and sin x is an odd function. Okay, and again one more thing, that is odd into odd is an even function, even into even is an even function, also odd into even is an odd function. Okay, when you by heart these two tables, you can easily get over to find what is the type of function you are dealing with, if it is an even function or odd function. Okay, let us check out this function f of x equal to x sin x, whether it is an even function or odd function. Okay, so since x raised to n, I mean x raised to 1 this is, right? So x raised to odd number is an odd function. So simply x is an odd function. Also sin x is coming under odd category. So again you have like odd into odd. So in total we can say that x sin x is an even function, and for even function we have like bn value 0. So for this Fourier series expression, our bn value is going to be 0. We don't need to find the expression for bn or solving it completely and get the value as 0. We can directly check out the type of function and write it as whether a naught is 0 or n 0 or bn 0, anything. Okay, but still we need to find what's the value for a naught and an. Okay, so the range is negative pi to pi, isn't it? So bn is 0, we need to find a naught value and an value. A naught value is 1 by range divided by 2. What's the range value is pi minus minus pi, isn't pi minus minus pi, which is 2 pi, divided by 2 is pi. So it is like a naught equal to 1 by pi f of x dx. F of x dx, which is 1 by pi integral x sin x dx in the limits negative pi to pi. Okay, here you can again see that the function here is algebra and trigonometry. So let us have table method here, x and sin x. Okay, derivative of x is 1, derivative of 1 is 0, sin x has the integration negative cos x has the integration negative sin x. go for plus minus plus, move for the arrows. See, if you you can check out the last video for this table method explanation, and answer is simply combine them up. X into negative cos x is negative x cos x, negative 1 into negative sin x is positive sin x. So the integration is that simple using table method. And before your limit substitution, please have a big brackets inside which you have need to draw two separate brackets, one for upper limit and one for lower limit. Substitute pi for x. It is like negative pi cos pi plus sin pi minus negative pi is given for x. So negative of negative pi is pi into cos negative pi plus sin of negative pi. Then it is like 1 by pi. See, cos pi value is negative 1. Okay. You can check out my previous video again here. Minus pi, cos pi value is negative 1. Plus sin pi value is 0. Minus pi into cos of negative pi. See, since cos is an even function, you can write like cos negative x is cos x itself. So cos negative pi is cos pi itself, which is negative 1 again. So it is like pi into negative 1 plus 0. So 1 by pi, negative pi into negative 1 is pi, and here also negative pi into negative 1 is positive pi. So the answer is 2 pi divided by pi, which is simply 2. So this is the value for a0. Now let's do an. An is integral f of x cos nx dx in the limit negative pi to pi, 1 by pi, isn't it? Just we had for a0. And it is like negative pi to pi x sin x cos nx dx. Remember, our f of x was x sin x. Never forget the question, okay? 1 by pi. Here you can see that two trigonometric functions are combined and we cannot have a direct integration here. Okay? Such cases you need to get help for trigonometric identities or trigonometric formula are many. I will write it. Sin A cos B is sin of A plus B plus sin of A minus B whole division 2. Okay, for this particular problem we can make use of this formula, but I think I should give you the other formula also from the same set, like sin A sin B equal to cos A minus B minus cos A plus B whole division 2. Also cos A cos B is equal to cos A plus B plus cos A minus B whole division 2. Okay. I said these two for reference only because when I speak about sin A cos B, you need to have idea about sin A sin B, cos A cos B also. For this particular problem, we just need this equation. So here we can tell like x sin x here, it is sin A here, so x equal to A, and cos nx cos B, so B value is nx. Okay. Now substitute the sin x cos nx using this equation. It is like 1 by pi integral negative pi to pi x into what is sin x cos nx. It is sin A plus B, which is sin x plus nx. Sin x plus nx plus sin A minus B. That means sin x minus nx whole division 2 dx. Okay. We have just replaced the question. Now we are moving on to integrate it. Okay. I think I can take this 2 outside, 1 by 2 pi, integral negative pi to pi. Let us have table method here again, isn't it? Here you can see this is A and this is completely trigonometric function. So we can have table method again, which means x and sin x plus nx. I think I can take, here you can see x and x here, means x can be taken outside, so that inside it will be 1 plus n of x, plus here also x can be taken outside. So it is like sine 1 minus n of x. Okay, 2 we have taken outside. So this is the approach for table method, and derivative of x is 1, derivative of 1 is 0. Now we have to have the integration here. What is sine 1 plus n of x? Integral sign is negative cos. So negative cos 1 plus n of x divided by 1 plus n. Integral sign again here is negative cos 1 minus n of x divided by 1 minus n. Again we have to integrate this. Integral cos is sine, simply sine. So negative of integral cos is simply sine. 1 plus n of x divided by 1 plus n the whole square minus again integral cos is simply sine divided by 1 minus n the whole square. Okay. Now please put the signs plus minus plus. Go for the arrows. There you have your integration. While after combining this everything, okay, it is like 1 by pi. How to write this? X into this complete quantity minus 1 into this complete quantity. Okay, so it is like x into minus, okay, this completely is the first term, and the second term starts with negative 1 into negative sine 1 plus n of x divided by 1 plus n whole square minus sine 1 minus n of x divided by 1 minus n of whole square in the limits negative pi to pi. See, this is a complex equation, but never be afraid of it because you are having sine for rescue. Why? Because the limits are pi, and you know that sine n pi is 0. Which means sine n plus 1 or 1 plus n pi is also 0, or sine 1 minus n pi is also 0. So in the very next step, this term will be getting cancelled. Let us see how it is going to be. It is very easy only. Never be afraid of such kind of complex trigonometric quantities when it is coming under integration. Okay, integration is a tough topic. Also trigonometry is another tough topic. When it is coming together in front of you, of course it is a much scary thing, but it is quite easy since we have this, I mean sine n pi equal to 0, sine anything into pi is going to be 0 only. So it is going to be quite easy only. Just check out. Please follow me. Here, when we are in a stage to apply the limits, we need to have two big brackets, one for upper limit and another for lower limit. Okay, so upper limit is pi here. Before substitution, have some mental calculation. So this is like x value is given, pi is given for the x value. Okay, so x is pi. And negative cos 1 plus n of pi divided by 1 plus n, here there is a bracket opening, minus cos 1 minus n of pi divided by 1 minus n. Okay, minus, I need to substitute this upper limit to the 4 terms written over here. Okay, I substituted pi value for this quantity which is reduced to this term, and this quantity again given to the second term which is now reduced to negative cos 1 minus n of pi divided by 1 minus n. And now we are going to substitute this pi for the third term, and third term is having sine, and we know that sine anything into pi is 0. So if I substitute this pi value over here, I get like sine 1 plus n pi, which is simply 0. Okay, so here you are getting like negative 0, this is coming like 0, and this is also 0. So nothing to return extra here. This is simply negative 0, negative 0. Okay. Now again move on to substitute the lower limit. Okay, it is like negative pi into negative cos 1 plus n of negative pi divided by 1 plus n minus cos 1 minus n of negative pi divided by 1 minus n. Okay, here again let me say that third and fourth term is having sign, so no need to substitute for it because sine any pi is 0. Okay, so our equation has been reduced to 1 by pi. Just check out pi, here negative is there, so negative pi into what is cos 1 plus n pi. Cos 1 plus n of pi is negative 1 raised to 1 plus n, because cos n pi is negative 1 raised to n. So cos 1 plus n pi is negative 1 raised to n plus 1. So it is like minus n pi, I wrote it together, minus pi, and cos 1 plus n pi is negative 1 raised to 1 plus n. Divided by 1 plus n minus, what is this? Cos 1 minus n of pi, which means cos 1 minus n of pi is again negative 1 raised to 1 minus n. Okay, so it is like negative 1 raised to 1 minus n divided by 1 minus n. Okay with that? And here it is negative coming here, and negative pi into negative cos. Okay, negative into negative, it is becoming positive, and it is like pi into cos 1 plus n of negative pi. And now cos of 1 plus n into pi. See, this is inside one bracket. Okay, 1 plus n and negative pi is in one bracket, because you can see that 1 plus n and x is coming together, isn't it? So 1 plus n into negative pi. So it is like cos 1 plus n into negative pi. As I have said, cos of negative x is cos x itself, isn't it? Cos of negative x is cos x itself. So it is like cos of negative pi into 1 plus n is simply cos of 1 plus n pi itself. Okay, so you can, here again it is like cos of 1 plus n pi is negative 1 raised to 1 plus n. So this term reduces to pi of minus pi is pi, and cos of 1 plus n into negative pi is simply negative 1 raised to 1 plus n divided by 1 plus n minus again cos of 1 minus n into negative pi. See, I have cluttered it. It is like cos of 1 minus n into minus pi, okay, divided by 1 minus n. So it is like cos of 1 minus n of negative pi is simply negative 1 raised to 1 minus n, okay, divided by 1 minus n. So that's it. Now please check out this negative pi into negative 1 raised to 1 plus n by 1 plus n, and here also same quantity expression. And here you can see negative of 1 into minus 1 raised to negative 1 minus n by 1 minus n, and here also negative of 1 into negative of minus 1 raised to 1 minus n divided by 1 minus n. Also there is a big minus here, so this term gets cancelled off. Thus our answer will be reducing to 1 by pi, and this term is repeating, right? It is repeating. Minus pi minus 1 raised to 1 plus n minus pi minus 1 raised to 1 plus n. So it is like two terms are repeating with a negative sign in between. So it is like minus 2 pi minus 1 raised to 1 plus n by 1 plus n. Okay. So the answer is, when pi is cancelled, it becomes minus 2 into minus 1 raised to 1 plus n by 1 plus n. Okay, this is your an value. So you have a0 value and an value. A0 value was, what was an value? A0 value is 2 and an value is minus 2 into negative 1 raised to 1 plus n by 1 plus n. So your f of x or x sin x expression can be written like, so you remember bn value was 0. Okay, so x sin x value can be written as a0 by 2 plus sigma an cos nx, which means a0 was 2, right? A0 was 2, so 2 by 2 1 plus sigma an is minus 2 minus 1 raised to 1 plus n divided by 1 plus n cos nx. This is your function x sin x, Fourier series expression. See, let us now check out one last problem from Fourier series. This is a CUSAT question paper, April 2019 supplementary exam. Here I saw one problem like Find a Fourier series to represent x minus x square in the interval minus pi to pi, our same previous interval, and hence show that this series is equal to pi square by 12. Okay, let me write down. Here this time f of x is x minus x square and the range is same, minus pi to pi. Here we have got a chance to check out what type of problem, what type of function is this, whether it is even function or odd function. Okay, also we have to prove, we have to show that 1 by 1 square minus 1 by 2 square plus 1 by 3 square etc. is equal to pi square by 12. Okay, so this part we have to prove it later, and this is negative pi to pi, isn't it? So as I have said, you have to check out which type of function is this, even or odd. Since x is having a odd power, this is an odd function, and this is an even function because x is having an even power, so this is an even function, and there is no rule like odd minus even is odd or nothing. It is just a combination of odd and even. So unfortunately here we have to find out for a0, an, bn as usual. No tricks are there like a0 or an, anything is going to be 0 or like that. Nothing is there. You just need to find everything in the usual procedure. Okay, that is very unfortunate, isn't it? So let us find out what is a0 first. So it is like 1 by pi integral minus pi to pi x minus x square dx, which is 1 by pi integral integral x is x square by 2 and integral x square is x cube by 3 with a minus in between. Here is a minus, here is a minus. Okay, so in the limit negative pi to pi, it's like upper limit minus lower limit, pi square by 2. See, substitute this pi value for x. It is pi square divided by 2 minus pi cube divided by 3. Okay, now go for this negative pi to x. It is like negative pi the whole square by 2 minus negative pi the whole cube by 3. So 1 by pi square by 2 minus pi cube by 3 minus, inside this it is pi square by 2 and negative pi the whole cube is negative pi cube. Send it, negative pi the whole cube is negative pi cube. Along with this negative, both negatives will give us a positive pi cube by 3. Okay. Now you can see pi square by 2 minus pi square by 2. It cancels off, and minus pi cube by 3 minus pi cube by 3. So it is minus 2 pi cube divided by 3 with a pi in the denominator outside. Okay, so the value is minus 2 by 3 pi square is your a0 value. Okay, a0 value is this thing. Now you have to find for an and bn also. I think to save the time, you can do it alone and see. I will give you the expression right now. See, these are the two answers for an and bn. For the time's sake, I have just written the answers because it is having the same procedures. I think we have done almost 3 to 4 an value, bn values solving, etc., isn't it? So I just wrote an value and bn value. Now I am moving on to the proof part, which is we have to prove this, isn't it? 1 by 1 square, this thing has to be proved. We have to prove this. How to prove 1 by 1 square minus 1 by 2 square, 1 by plus 1 by 3 square, etc. equal to pi square by 12. For that, I need to write f of x, our Fourier series. F of x equal to a0 by 2 plus sigma an cos nx plus sigma bn sin nx. Okay, which means f of x is x minus x square equal to a0 by 2. a0 by 2 means a0 is minus 2 by 3 pi square divided by 2. Okay, 2 I have written in the denominator plus sigma, what is an? An is 4 by n square minus 1 raised to n plus 1 plus sigma cos nx plus sigma n equal to 1 to infinity. What is bn? Bn is 2 by n minus 1 raised to n plus 1 sin nx. Okay. Now, please check out the series. The series is having only square term in the denominator, which means we can generalize it as n square, isn't it? When n is given 1 value, 2 value, etc., it is like coming up 1 square, 2 square, etc. So, we need the term containing n square. Let us check where is n square term coming. Here you have 1 n square. So, we need to maintain this quantity, but we don't need this 2 by n quantity. Okay, so this quantity must be ruled out. This term should be 0. How can this term be 0? Just give a particular x value so that this term completely is going to be 0. Here you have sin nx. So when does the sin nx is going to be 0? When x is given 0 or pi or etc. Okay, let us substitute x equal to 0 and just see what is going to be this. Okay, so when x is equal to 0, this term is going to be like 0 minus 0 square is 0 equal to minus 2 by 2 is minus pi square by 3. Okay, 2 gets cancelled off, plus sigma n equal to 1 to infinity 4 by n square minus 1 raised to n plus 1. What is cos nx? Here cos n into 0, which means cos 0 is 1. So it is simply 1, and here it is sin 0 is 0. Okay. So we just arrived in this simple small equation. Let's rearrange it now. It is like minus pi square by 3 getting to LHS, it becomes pi square by 3 plus equal to sigma n equal to 1 to infinity 4 by n square minus 1 raised to n plus 1, isn't it? Now let us expand the sigma notation, like pi square by 3 equal to, when n is given different value, I mean starting from 1, let us give different values for n. Okay, so it is like 4 by 1 square minus 1 raised to 1 plus 1. Next term is n is given 2. So it is like 4 by 2 square minus 1 raised to 2 plus 1. Next 4 by 3 square minus 1 raised to 3 plus 1, etc. Okay. So I think I can take this 4 outside from every term. 4 is taken outside and it is like pi square by 3 is equal to 4 into, what is minus 1 raised to 2? 1 plus 1 is 2, isn't it? So minus 1 raised to even number is 1. So it is like 1 by 1 square plus 4 is taken outside. It is like 2 square coming here. Minus 1 raised to 3 is negative 1 plus 1 by 3 square. Negative 1 raised to 4. 3 plus 1 is 4. So it is 1 and it goes on. So it is like pi square by 4 is taken to the denominator in the LHS. It is pi square by 12 is equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square, etc. Okay. So this is how you derive 4. So friends, we checked 5 important questions from Fourier series chapter. I think it is clear for you, and next topic will be differential equations and vector calculus, etc. and etc. Meanwhile, I will be uploading electrical, graphics, mechanics also. So please stay tuned for the videos and please try to get high marks for your supply exams. And if you like the video, please like, share and subscribe it. Thank you.